Hi, my name is Ken Owens. I'm here to talk about the data divide, an end user's cloud native journey to distributed databases. You can find me at Ken Owens 12 on Twitter and on LinkedIn. I'm a technical executive with 20 plus years experience in the financial services, communication systems, and technology services field. I love technology, and I'm a technologist at heart. I have my formal training in electrical engineering and a lot of system engineering, embedded system design, development, and innovation over the last 20 plus years. And then in my personal time, I'm a husband, a father. I'm involved in my community and in sports and in the outdoors. So today, to kind of talk about, what is the data divide? I'm going to discuss a little bit why it's distributed databases so hard. Present some of the lessons that I have learned at Mastercard, and then talk about what's next in this journey towards distributed databases. So when I talk about the data divide, I think it's important to kind of go back and think about what is cloud native, right? And in the CNCF, we have this definition that I've kind of highlighted a few keywords here that are around dynamic environments, loosely coupled systems that allow engineers to make high impact changes frequently and predictably. And looking at more state-of-the-art patterns that make innovations accessible to everyone, right? And so the definition of what cloud native is very complex in nature and very focused on the build and running of applications, not so much on the underlying services and infrastructure. So that's where there's a divide that kind of comes up. When you think about distribution of database services, right? Database and services within databases have great gravity. It's not so easy to sort of separate out where the type of data and the classification of data and how that data resides, the life cycle of that data is a very complex problem. At Mastercard, we have sort of split the problem up into a databases sort of group, and then we have our application developers who own the schema. And so when you kind of separate out what the infrastructure is owned by one team and the data and schema is owned by another team, you add some complexity to that database service, right? We have as you can see on the right-hand side, we have quite a few different types of database technologies that we support today, and numbers of instances of them. And these are all in production type of database services instances. The database team in Mastercard supports sort of the 2,500 plus databases across the 6 different technologies that we support. We're responsible for the install, the upgrade, managing end of life, the patching cycles, any vulnerabilities that come up. The team kind of owns the whole life cycle of the database platform and infrastructure that it sits on. And the team also is responsible for defining and monitoring the different standards that need to be created around how to manage and maintain and support the databases and the schemas within those databases, along with how we operationalize any new technologies that are needed by the business. So if you kind of break down what does that capabilities look like, I kind of like to start with the bottom. We have this architecture design team that sort of focuses on how to structure distributed databases and how to manage and maintain those databases across a large spectrum of different deployment types and scenarios. We have a support group that's responsible for like the monitoring, the backups, end of life support, patching, security vulnerability updates. And we have what we kind of call an automation team, for lack of a better word, that is focusing on sort of how do we automate everything that we do, how do we automate the database, how do we automate the standards we come up with the database, and then how do we take problem resolutions and kind of automate how we fix those database issues and problems in real time. Some of the focus areas that we have for distributed databases are around the number of alerts that we get, and so we're averaging over 5,000 plus production alerts per month, and that's quite a bit of noise if you're thinking about how much a database alert should be generating, right? We have lots of gaps in our support coverage and in how we monitor databases across different application portfolios, and that's mostly driven by not adhering to standards and some of the compliance and regulatory pressures that we have in our industry. There's also some inadequate and improperly used backup storage space, and so how we maintain and properly back up our data is a big issue that we are focusing on as well. Being that we have been in business for some time, we have a lot of end of life products that we are managing, and deployment time is very handcrafted. Is probably a big focus for us right now. Is how do we make it easier for application developers to sort of deploy their applications with the right data services, which you'll see as part of this talk today. So if you think about why distributed databases are hard, I kind of look at it from two different aspects. And the first aspect is sort of this, the application developer persona. And when a developer is thinking about how they're going to roll out their code, the first thing they're kind of thinking about is what are some of the principles around defining and deploying code, right? And unfortunately, today in a large enterprise, this is very complex because while a developer wants to just think about how do I run my code, they have these different change review boards that have to get involved around like infrastructure changes, platform changes, the different dependent service changes that are needed, the business impacts and financial approvals that are needed, and other aspects along those lines, right? And so when you kind of think about these change boards, they're large boards of individuals from different groups that make up different aspects and different decision points within the business side or in the infrastructure or platform teams. And on the infrastructure side, you're looking at the network teams and the compute and storage and virtualization teams and different aspects that make up how do you deploy infrastructure and support infrastructure and make sure that the monitoring is in place. And so as you kind of go through this chain of controllers, if you will, you kind of have the business, admin looking at the financial aspects, looking at how to prioritize this application. Then you have within that group, you have other individuals or teams within those areas that have to go through the different reviews and build the business case and get the approvals up to the CFO in some cases. And then when you think about the infrastructure side, similar efforts are taking place within the infrastructure teams, where you have like your network engineers and your monitoring team looking at how to monitor this. And all of this happens for every application and every time an application wants to deploy a change into the environment. And it gets very onerous on a developer to have to try to remember what they did last time or who had to give the approval last time, and it becomes more of a game of kind of tracking how do you get through this platform system approvals versus just writing the code and deploying it, which is what we're trying to accomplish in this cloud native space. And so within that platform change, I have a team or teams of individuals that are helping to support and ensure that the application team is developing their code and putting the right validations in place. You have different compute and virtualization and monitoring and network teams involved to ensure that they understand how the impact on the infrastructure is going to be. With databases, that's very much around kind of the storage and how the storage is configured and what type of standards are supported in the large enterprise for databases. And you get down into the service areas, you have your EAs, your individual service teams on authorization and access and message queues and other aspects that make up components that the application needs. And database is one very critical component there. And that's where, as part of this whole overall flow, right, the developer has to think about not just, their application architecture, but also each of these individual teams and these different meetings and these different architectures that are needed from each of these teams in order to move their application forward. And part of that's just not something that you want to have to be pushing forward all the time to your development teams. And so as you think about where we're going and what we want to do with databases, we really want that database schema to be part of the application deployment. We want these approvals and some of the validation that's needed to be baked into the delivery of that application service on the database configurations and the database management and the monitoring that required for the databases to be a standard across the organization. The other aspect is for the platform teams and the infrastructure teams, right, there's a large gap that exists today between sort of what I call solutions and services. And so if you think about the graph I showed earlier with a lot of Oracle and Postgres databases, the way that we've sort of matured our processes in the enterprise around kind of these solutions that are given to us by a vendor is a lot different than how you consume a database service in the cloud, or in a set of curated experiences that get built in sort of a cloud native data model today. And so trying to look at those different technology gaps that around resiliency, around availability, around replication, right? There's a lot of different aspects that come into play with these gaps in the services and the solutions, that it becomes quite complex for development teams and infrastructure and platform teams to really understand, how do I understand the needs of the business and the requirements of the business when they're just asking to push this code out. I don't know what the code is trying to accomplish, or how much of a reliability or compliance requirements are on that code. So trying to identify that is a big gap that we're trying to figure out within a technology space. Another one is kind of going back to the cloud native definition, right? Whenever you talk about dynamic environments and you talk about data, it's a little bit difficult for data to be dynamic, right? By definition, data is somewhat static, and it's somewhat point in time and very reliant on what the context of that data is. And so being able to sort of move data around, have data reside in multiple locations and get updated in real time across the globe is a very complicated problem that the cloud native definition can kind of contradicts the way data works today. And so trying to figure out how to make data more dynamic is a big part of what we're working on as well. The other part of that definition talks about these loosely coupled systems. And so as you think about applications and the data that reside for those applications, and you think about the services that are offered in an enterprise service offering, there is not much of a loosely coupling between application and data. And so trying to think about, how do you take this definition of a loosely coupled data service, available and resilient and manageable across multiple different geographies or different service endpoints that are trying to access that data for fraud detection, for instance, becomes a much more complicated problem when you're looking at data. And then the last one from the definition is this, making high impact changes frequently and predictably is not as easy as it sounds. When you think about data again, and the databases and how you maintain and support these databases, there's a lot of predictability there, but high impact changes in data don't necessarily go well in the same sentence. And so that's kind of one of the areas, again, that makes it difficult to think about, how do we as a technology company provide this type of services that our business needs in a way that's not going to impact the security and availability of this data. So those are sort of the two main parts of today's presentation. Kind of skipping to what have we been kind of learning from our lessons learned standpoint at Mastercard. It's really all about the culture, right? And I can't say that enough. That's why I said it 3 times. It's really important to get that culture right. And when I talk about culture, I really think about the people and the process first. Cloud native is really an open source first model, right? And so what I mean by that is, as you're moving down this path towards cloud native, all of your different infrastructure and platform and application teams need to understand how to kind of contribute in a way that is more of an open source model versus your traditional, build a service internally and maintain that service within a small team, and never update that service outside of a change window, right? So as you think about more of an open source model where you're putting pull requests out there, and you're making changes in a much more dynamic manner, there needs to be a lot of education and training around that, and you need to build a culture around how to sort of develop software in this new model that is more open source like. And there is definitely a need for an open source program office in the enterprise space, and how to maintain and manage that over time is a very key thing to consider. One of the other principles that we've been looking at is that not all of the cloud native principles are understood equally. And so there's a lot of discussions about what certain aspects of cloud native means. And then we often kind of repeat that discussion over and over again. So there's a rinse and repeat often sort of mentality that needs to be developed within the enterprise space, where you're always helping your developers and your platform teams understand what these different principles mean, and how that meaning should be the same across all of the different teams. And then it's important to put some governance around the principle so that you're not just telling people here's what you should do, but then you never validate or check that they're actually doing it. So governance is an important thing to put in place, not so much to like penalize teams for doing things wrong, but to help educate them and kind of go back to that first cloud native open source model, right? Mentality I brought up at the beginning of this, where you want to kind of encourage the right behaviors and then kind of, when you see those behaviors, sort of help, enforce those types of behaviors and continue to grow the culture of the organization towards that model. Another lesson we've learned is around the in-state capabilities. And so we found, very, very early that as technologists, it's very easy and fun to go out and just look at all kinds of technology and build great solutions that never get used. And so it's really important to kind of think about the in-state capability you're trying to build first. And so to do that, you kind of look at, how do we organize these capabilities around a business value that we're trying to deliver? And then it's important to have measurements for that business value. So just saying you want to build a core service and it's going to help this business and this business value in this way, but you never measure that, doesn't really help you as an organization. So it's important to define your organization and organize you around your capabilities that are in support of that business value, define the measurements for that business value, and then over time you want to optimize and scale and that performance and optimize your performance around that business value and those measurements. And it's also important as part of this in-state capability to focus on what I consider that end user or that end customer experience. It's really important, and especially in this sort of a model, you want to make sure that you're very focused on how you're delivering value and how you're improving the end user experience that you're trying to deliver to your customer. So those are kind of the people and process piece. The next thing then is sort of, looking at technology, because we are engineers, we are technologists, we love technology, right? And so it's important though that you look at technology through a lens that it's a means to an end, but it's not the end. It will help you accomplish your business goals, but you can't get so tied in or so coupled to a technology that it becomes the only thing you're focused on, and you lose sight of the business value you're trying to deliver. And then you obviously want to measure your business outcomes both from the in-state capabilities you're trying to deliver, but also from the technology that you're using to deliver that. So you kind of measure those business outcomes and then continually iterate on top of that. So as you evolve and develop this distributed data patterns and services you're developing, you want to continuously have this iteration mindset where you're continually improving those services. So in terms of kind of like distributed databases and what's next, there's sort of four main things I want to kind of leave as takeaways. And so the first one is that part of what I think the industry is doing and what Mastercard is very much involved in doing is application developer leveraging just the data service as a standard API and standard data patterns. And so moving away from snowflakes, moving away from custom database models, moving more towards a set of data services and standard APIs and patterns that can be leveraged, not just on existing capabilities and services, but the business services that are being developed in this new data model that we're trying to build. So it's kind of a both and sort of model. The second takeaway is that when you're looking at these data services, they need to be, the monitoring, the logging, pretty much the entire lifecycle aspect of data has to be part of those patterns. You don't want to kind of create like a data pattern that doesn't have a lifecycle pattern associated with it. And that when you do this correctly, you're sort of separating that platform piece from the developers, right? So developers don't have to worry about how they're going to monitor and how they're going to get logging for their data, which is, as I mentioned at the beginning of the discussion, there's a pretty big issue at large enterprises where the data sets are defined by the developers and they're kind of ad hoc and all over the place, and sometimes they don't cover all the needs that the business has. And so building that into your pattern takes that burden away from the development team, puts it back on the platform team to make sure that the business is getting the monitoring that they need and that the platform is getting the monitoring that they need. And then you have sort of a common data model that can be supported by the business and help can grow the business and the needs of the business. It's a very important key takeaway from the lessons we've learned. The third thing is that the data service catalog is something that we're trying to construct now, and it's being constructed more of like patterns that are focusing on the business requirements. And so some of our business requirements require, because of compliance and other types of security concerns, on-prem only type of service. Some of our patterns support cloud. Some of our patterns need to be have been developed around the on-soil pattern that I know from some of the nationalism that's going on in the world, that we want to keep all of our services within one, country, so that nothing can leave that country. And then you have, the hybrid of these different solutions that exist as well. And so the big key for us is to kind of create this data service catalog that allows us to meet the business needs of any of these types of use cases without developing multiple patterns for each use case. So develop a single data service that can be constructed and consumed on-prem is the same pattern that would be constructed and consumed in the cloud or in an on-soil use case or in a hybrid use case. So the pattern doesn't change just based on where you're deploying it to is the key. And then the last one is kind of an exciting concept that we're working on called a data mesh. That's kind of similar to service mesh if you've been, kind of following the service mesh methodology and technology discussions out there. What we're thinking of and starting to do some development around this concept of a data service control plane that has this abstracted data service model. And we even started talking kind of like custom resource definitions. We've been talking about custom data definitions where we can sort of build abstracted data definitions that can be consumed in different ways by different platforms. And so there's not a whole lot of industry effort around the data mesh yet, but we're starting to have some discussions with the open source community around data mesh, and hopefully in the not too distant future you'll hear more from Mastercard and the community on the data mesh. With that, I'd like to pause here, and we have a few minutes for questions, and I'm happy to take your questions right now. Thank you very much for your time.